All right, it's 11:01. I think some of the Celgene folks are off-site this week, so we won't have a big crowd. But we still wanted to go over sort of some of the exploratory data analysis stuff with cooking when our Clarity NLP session. So we'll be introducing Engrams, topic modeling, and some visualization around that, and sort of a lot of the other features of Clarity NLP. If anybody joins and has questions along the way, feel free to just shout them out. Christine and I are going to sort of tag team back and forth. If you wanted to do sort of like get introduced to Clarity NLP, you can go back and look at some of our previous sessions or look at the documentation. Basically, to get going on this, you need to have Clarity NLP running, and you need to have some documents loaded into Solar. And we sort of picked three big topics to do topic modeling and Engram search around, and Christine's going to dig more into that now.
Yeah, thanks, Charity. So this morning we're going to talk through 3 different phenotypes that you might want to develop. Before we dig into what those are, I think it might be helpful for us just to chat briefly about why unsupervised learning might be useful in this process. So a lot of times when we talk about phenotype development historically, and for a lot of people that we work with even now, this tends to be a rule-based approach or a heuristic approach where you have a couple constraints, and these are typically quantitatively expressed, and generally, most of the time at least, you're able to extract the sort of features you might constrain on from structured data. So it might be, for example, an age threshold, it might be a gender or race-based cutoff, and it might also include diagnostic criteria such as a value on a lab score above or below some number. So these types of things are extractable from structured data, from claims data more specifically. Of course, you still have to go through the work of transforming the requirements to code, but there are sort of an established set of practices for how to do that. And it's also much easier to validate whether you've done it correctly, because it's more simple to get a truth value for metrics that are quantifiable. Now, when we have other things we might want to consider, such as the social, cultural, behavioral determinants of health, including some of the terms in the list I've got here, for example, poor social support or isolation, homelessness, substance abuse issues, socioeconomic status or duress, financial distress, domestic abuse, insomnia or trouble sleeping, poor compliance with required medications. And this is not an exhaustive list, so we could certainly consider other items here. These factors are much less likely to appear in structured data. There's almost no chance that you'd be able to recover most of these from claims data. However, oftentimes if patients mention these items with their doctors during a consult or some other thing, they might show up in the notes. So what we're going to walk through today is how you can use various functions from Clarity NLP to extract or sort of use these phenotypes or set membership questions for feature engineering. And you'll notice as we go through this process that it's designed to be iterative. So at no point do we ever really get to say that we've defined an exhaustive set of items. There's not a clear-cut way to validate our process either. So it's intentionally designed to require human in the loop at multiple points along the way. And we sort of have to, take our initial knowledge, run some models, get the output, match that against what we've already know, and sort of refine as we go. And how exactly we refine will depend on the problem we're trying to solve, and hopefully that will become more clear as we walk through some examples. So for today, we're going to talk about 3 different set membership problems. 1 will be homelessness, 2 will be insomnia, or more broadly, trouble sleeping, and 3 will be poor medication compliance. And it's important to note that generally when we're looking for these things, we not only want to determine if someone is currently experiencing these conditions, we might also be interested in recovering for the sake of feature engineering if someone has experienced these conditions in the past. And of course that past might be time bounded by a particular window. We're not going to get that specific today, but it certainly is possible with the combination of restrictions from structured and unstructured data. So the way we start this process is we brought in John Duke, who's our clinical team member, and we talked amongst ourselves as well. And we developed sort of a starting term set that you might expect to see these terms in notes if patients are in fact experiencing or have experienced these conditions in the past. And you'll notice by looking at this list, there are some terms, for example, in the list of terms under homelessness, we see eviction and evicted. So these are different parts of speech, but sort of the same root word. So lemmatization can be helpful in this process. And you also might be interested in expanding some of the terms. Let's say, for example, you're not feeling particularly linguistically creative and you want to algorithmically determine all the synonyms. So fortunately, Clarity NLP has built-in functions to handle that. And I'm going to pass it back to Charity, so she can walk you through those.
That was not planned.
I promise.
So this is a thing that Richard Boyd developed for us, and we talked about it a little bit last week. So it's sort of like Christine mentioned, you kind of have to manually curate it and sort of examine, what makes sense. What do I want, say, like a common synonym, or what do I want, say, maybe a clinical synonym? So if you want like a clinical synonym, like in this case for insomnia, I wanted to use the Odyssey, like the OMOP dictionary for synonyms. Versus homeless, I thought that'd be more likely to gain more terms by just using standard synonyms from WordNet. And there's also, like Christine mentioned, with evicted and eviction, we can also do word inflections, and we can sort of combine all these things together. So for each of these terms, I sort of went through each one that Christine and John came up with, and I wanted to expand each one of them and see if we could gain any other terms that might help us if we're trying to sort of categorize these populations. And it's pretty easy, basically, just like you would set up a term set in NLPQL. There's a preprocessor that basically runs all these calls and expands these terms with any matches that it finds. So if we can run that, and we have run that, and we can see we get a lot of results. So some of these are really meaningful. So with homeless, we picked up homeless person. With frostbite, we picked up something. With evicted, the verb inflections, we picked up the different verb forms. So that's pretty good. We don't want to use all those because obviously like tax shelter doesn't make any sense. So we'll probably want to filter that one out. If we look at insomnia, we use the OMOP dictionary, so we got lots of new word variations, some of which are good and some of which are probably bad. So maybe some of these with just mentions of disorder, which is like the SNOMED terms, we probably won't see that too much in the text. So we probably want to filter those out. Some of the British spellings probably don't make sense for our data set, but for other data sets, they certainly make sense. And then with fatigue, we found some good words like tiredness, weariness. And then if you scroll down to compliance, we got a few good word variations with afford and affordability. But what we found with this is really good for expanding sort of our vocab for when we're doing the NLPQL, but we found it's probably too much. So in this case, we manually created that list down. There's other methods you could use to sort of more quantitative approach to prune the list down using information theory. So the easiest one might be to just look at the tail and chop off the tail. So look at the distribution of these terms in your data set, and you could do that with some of the query tools that we have, and then maybe chop off the least common terms. Another approach might be measuring entropy. So now that we sort of have some initial query terms, we've taken the initial list sort of by our team of experts. We've passed it to the term expander and got additional set of terms. So now we want to run Engrams. And just to introduce Engrams really quickly, we'll start with homelessness. Basically what we did with each of these is we went through each set, we built an NLPQL, we evaluated each one, and then we got the results back, and then, and then we basically talked about, we'll evaluate the results. And what Engrams are, if you don't know much about them, it's basically just like phrases or blocks of phrases that you can use. Can you scroll back up for really quick? So it's a pretty simplistic metric to measure terms and words, but when you pass something into it, you can get a lot of information out. So if you're passing in, can you scroll back up a little bit more? Sorry. Oh, sorry. So this is, sorry, I got messed up. Yeah, so this is where we found patients that that match those terms. So that was our first step, was to find patients that match those terms. And then once we've done that, we ran Engrams. So like I said, Engrams is a pretty simplistic measure to find common phrases in a document set. And Clarity already has a function built in to run Engrams. So you can filter it on a lot of different ways. So if you just have a query you want to run against, so you want to just look for the word homeless, you can limit your Engram to the term homeless. If you have a certain document set you want to run, so maybe you want to run Engrams on discharge notes, for example, in your data set, you can do that. Another feature that we've recently built is to take results from Clarity and import that in as a cohort as well. So kind of like I skimmed through in the last section, we ran each of those term sets on Clarity. We found patients that match. And now that we have those patient lists that match, we want to filter on them and just run Engrams on those patients. So in this case, we created a cohort. We called it Clarity Found Homeless Patients. And then just the way you call it is similar to all the other Clarity functions. It's called Get Job Results. And you'll need to pass in a context, which is either the patient or the document. And you need to pass the job ID. And you can see like this job is the result of the previous job that we ran. So that job ID that you get back from the previous result, that will get passed in. And now that we've run that, we can run Engrams. So Engrams give you lots of options. 3 is probably the most common number. So that's like phrases of 3 words. So it's like dog ran fast or heart attack patient. So there's different. You can try different numbers depending on what data you're trying to find. We have different options. Basically, it uses textity under the covers, so you can filter out numbers. You can filter out stop words like and, but, or. You can filter out punctuation. So maybe you don't want that in your set. You can apply a minimum frequency. So you want an Engram to occur at least so many number of times. And you can also set it to do lemmatization, which lemmatization is to take the form of the word and take it to the root form of the word. So for example, in our eviction example, it would take eviction and evicts and evicted all back to the root word of evict. So now that we ran that, we created Engrams on each of these. The other option we have with Engrams is to limit to a term set. And what that does is, given in this case, we have a set of homeless patients, so we've already limited the data set down pretty far. But maybe we want to limit our terms that we find just to words that mention homeless. So if you do this, not only will it query on the term homeless, but it will also only match Engrams that have the word homeless in the phrase. So we ran that for each of these. And then Christine created a distribution of what other words occur with homeless. So in this case, we were trying to visualize, and we did it by frequency, and we wanted to find what other words occur with the word homeless, because we're looking for Engrams just on homelessness. So what other things can we find? So it makes sense that a lot of stuff we see is like demographics. So we see man and male. You can see that female is in there too, but at a much lower frequency. You can see woman in there. You can see homeless. You can see outreach, homelessness. So it makes sense that these are sort of words that co-occur with homeless and sort of what we would expect to get from this data set. With insomnia, we saw a similar thing. So we see some things like related to how people are sleeping, like disturbance or agitation, delirium. And then as we go further down, we see stuff related to the prescription and restlessness. We also see mentions of Ativan and anxiety. So there's some of that mentioned with maybe this person has anxiety and that's why they can't sleep. So this sort of gives us an idea of what sort of other terms occur with insomnia. If we go down to poor compliance, and in general, we just wanted to mention that this is a mimic data set. So this data is obviously on inpatient ICU patients. So compliance is something that's a little bit trickier to do with inpatient patients. So we just wanted to make that clear. So some of the compliance stuff, we didn't really pick up what we were expecting, which I guess in our case is good, since we're just doing sort of exploratory data analysis and see what we can find. And you'll sort of see that as we go through this notebook a little bit further. But we do see mentions of noncompliance. We see some of the other procedures that people are taking. So there wasn't as much that that pops out with poor compliance. But I think we'll dig into that in some of the topics, and that'll give us a better idea.
Yeah, so just to sort of tie up there, with respect to compliance, I'd also just point out that the term set we entered as our initial set is deliberately pruned. So like I made a large list and John came back and chopped it down. So by doing that, right, by putting generic terms such as compliance, and afford, you're sort of getting at two possible expressions of non-compliance, which would be specifically, explicitly stated as person X is not compliant with their medication regimen, for example, or person X can't afford their medication. There are, of course, other ways you can be non-compliant that are not necessarily specific to medication. There are also other contexts in which the term compliance might come up, including regulatory requirements, including end-of-life care, particularly for people who are intubated, and these are ICU patients, so that does become more relevant here than it might be in the general population. So we'll get to that more as we go through topic modeling.
Yep.
But one thing I want to touch on before we do that is from a computational perspective, each term we add has a cost, and the more terms we add, it sort of becomes combinatorially more expensive to keep throwing terms in. So Charity talked about how we manually pruned the results we got back from the term set expander. Another thing you might want to consider, for example, is when you run your NLPQL query and you get back a data frame. That data frame is going to include a column called term. And that term is going to show you the particular word that caused Clarity NLP to return this sentence as a match. So essentially what we can do is plot the distribution of matches to help us understand where we get the most bang for our buck and where, if we have to chop the distribution, would be a logical point. And as you'll note, for the things that we're looking at today, the distributions are all highly skewed, so they all have long tails, and they do appear to be logical places where if you had to refine your query or reduce the amount of terms you're looking for, there would be logical places to do it. So for example, we look at homelessness, and I wrote a plotting function here that removes case sensitivity as the potential reason that terms might appear to be disjoint, even though they are in fact semantically the same. But they might appear differently spelled in the actual underlying data. So you'll notice, for example, that for homelessness, the three most salient terms that cause matches are exposure, homeless, and shelter. And these are logical, not necessarily surprising, but we don't, for example, get really hardly any matches from eviction or evicting. Vulnerability also not very helpful, and frostbite generally not helpful either. So if we had to make a cut, those first three might be logical to keep in our data set.
And in this case, we might want to dig into exposure more, because exposure could have different meanings depending on the context.
Yeah, and in fact, like just from manually reviewing some of the notes, exposure, particularly for this set of patients, can mean exposure to the elements as we might have originally expected. It can also mean exposure to things like hepatitis or HIV or substance abuse or some sort of physical assault as a result of being in a homeless or generally vulnerable population. So yeah, that's important to consider too. For insomnia, we see a little more variation, but generally we see fatigue, tired, and sleep apnea come up pretty strongly. Restless leg syndrome, much less so, and poor sleep. I mean, a lot of these are synonyms, so there's some interchangeability there to consider, but restless leg syndrome, for example, versus sleep apnea, it does appear that sleep apnea is much more strongly co-occurring in the data set. Finally, for compliance, we see that compliance is the overarching or dominant term here. Adherence also comes up, but much less likely. And afford and expensive, which of course are references to the cost of medication, do appear, but they're much less visible than compliance itself. So now that we've taken a look at our terms,
Do you want to take a moment and see if anybody has any questions?
Yeah.
Does anybody have any questions about what we've done so far with Engrams or term expansion or any of the other features with Clarity?
And one thing I'll point out, and of course do feel free to speak up if you have questions, before we jump to topic modeling, Charity briefly mentioned that we've made it possible to chain queries. So I just want to sort of emphasize here that that's generalizable. It's not specific to, for example, NLPQL to Engrams. You generally can chain queries, and it's you can chain multiple queries. There's no real constraint aside from the processing time on how many results you could chain together. So this makes it much more straightforward to build sort of a natural machine learning pipeline that people working in that space might be more familiar with, where you use the output of one function as the input to another function. And in doing so, you don't have to, like, for example, recompute from scratch the down selection of step 1 to run step 2. So this has implications for the overall cost and processing time, and we're actually sort of experimentally going to try and make that even better. So that's something to look forward to in the future.
And it's pretty flexible, so depending on what results your algorithm generates, obviously you can do it inline in the NLPQL if you wanted to do some sort of filtering. But this sort of gives you another step. Say if you want to run job 1, get results back and sort of explore that, and maybe you only want one feature to reuse, and then feed that to machine learning because maybe you have found patients who have prostate cancer and your algorithm successfully identified that. Now that you have that sort of cohort of patients, just like an OMOP cohort of patients that were identified from the structured data, we essentially have the same thing with a cohort of patients generated from Clarity.
Right, and we don't exactly have it in place yet, but we hope to soon basically have the results returnable or queryable as a Boolean vector in addition to as a document set. So, for example, if you're constructing a feature matrix, that type of result might be more immediately useful. So that's another thing to look forward to, hopefully in the near future. So if no one has questions, I will jump to topic modeling. So we are, for the sake of time, not going to get too much into the weeds here today, but suffice it to say there are generally topic modeling, of course, refers to sort of an unsupervised approach to trying to extract or discover latent semantic structure within a text or a group of text documents. So one important point to realize when you use these kind of methods is that there's no guarantee going into it that you're going to get back a set of topics that are human interpretable. Of course, they will contain words which have dictionary meanings and perhaps clinical meaning, but the exact linking of these terms you're not guaranteed to sort of get thematic buckets. And this has not been done ahead of time either, which is what we mean when we say it's unsupervised. It's better to consider this set of algorithms as a data mining process rather than a supervised learning process. And it can help you uncover patterns, but it's not guaranteed to give you something that you can immediately use. It's generally something that you're going to have to think about, requires domain expertise in some cases to make sense of as well. So there are two main approaches, and of course these have been, people have written many, many papers with subtle modifications to each of these algorithms. In general, LDA and NMF are two commonly used algorithms for topic modeling. They are both wrapped in scikit-learn, and they are also exposed as parameters in Textasy, and we are wrapping Textasy right now. We may end up writing some or perhaps all of this from scratch as we move forward, as we think about how to parallelize this in the smartest way possible. But right now, and for the sake of demonstration, we are wrapping a Textasy call. So LDA, generally, you can think of as a generative probabilistic model where we look at documents being modeled as mixtures over an underlying set of topics, and then topics in turn influence the probability that a certain set of words will be present in a document. Now, these distributions are both understood to be highly skewed, and the way to interpret that meaningfully is that for any given topic, only a small set of words are actually likely to be highly probable to be present, and many other words, the majority of words, in fact, for the corpus, are going to have probabilities close to 0. And NMF is sort of a linear algebraic approach to the same thing, where you have a large matrix. In this case, it's basically the document term matrix, where each row represents a document and the columns represent terms, and the cells within each row basically represent either raw counts or TF-IDF values. There's some flexibility there, and you're basically trying to factor this large matrix into two much smaller document topic matrix and a topic term matrix. And I posted some papers here and resources that you can dig into, and I will update this list after our chat today with some more resources that might be helpful. It is important also to realize that for both of these algorithms, and generally most of the exposed APIs you'll find, the number of topics is a parameter that you have to pass as the user. It is possible to think about this as a hyperparameter optimization problem, and there are numeric and quantitative approaches to choosing the optimal number of topics. Those methods are not really in scope here, but we will probably try to incorporate that type of logic eventually into the pipeline. Generally, it's sort of information theoretic about how many topics you can add before you get really into the weeds. So that's sort of just an intuitive way to think about it. So in general, the pipeline that we construct for topic modeling requires us to construct a text-to-see corpus so that we can use the text-to-see API. We then train and pickle our topic model. Here we are using NMF, and I have generally required the number of topics to be 10, and then the number of terms per topic to be 15. And these are just the helper functions that implement those models. Now, what we do here is we load up the results that we got from our NLPQL for each of our phenotypes. So the first one I've done here is homelessness. We convert that into a text-to-see corpus, we load the corpus, we train the model, and then we look at the topic vectors. And, as we sort of mentioned earlier, this is where some interpretation is required. So, reading through this, we make a couple of observations, which I sort of called out in the comments. For example, you notice topic 1 includes reasons why homeless patients might be compelled to seek shelter or appear present for treatment. Remember again that this is mimic, so these are ICU patients. So for example, in the event of an ice or storm or in general severe weather conditions, many cities have laws in place requiring them to send buses around to take people to shelters. And that might be a situation where someone who has an underlying medical condition or is impacted by this weather event and is indisposed in some way might be compelled to present at the hospital when they might otherwise not be. So that's sort of intuitive there. Additionally, many of these topics contain references to several vulnerable populations that we know statistically are perhaps overrepresented in the homeless population relative to in the general population. So these include veterans, which you see mention of in topic 2, people with substance abuse issues, which you see in topics 3, 4, and 5, and people with mental health issues, which you see in topic 6. So those are just sort of some high-level reflections on the topics here. We do the same thing for insomnia, following the same pipeline. For insomnia, when we look at the topic vectors here, we have a couple observations. For example, topic 4 is clearly related to sleep apnea and the associated medical devices you would use or be prescribed if you are diagnosed with sleep apnea. And that is, of course, something that might cause you to, come under study for sleep-related reasons. Topic 6 appears to be related to people with cardiac and or respiratory conditions, which generally, of course, might also have results in you having trouble sleeping. Finally, topic 9 appears to be related to anxiety and associated pharmaceutical treatments for anxiety. You see, for example, Advine is called out there. And of course, if you're anxious, you might have a harder time sleeping at night. So these are intuitive, and they also help us think about what clusters of patients might exist within these broader populations and what might be driving these people to be classified under, for example, homeless or people with insomnia. Finally, for compliance, again, our pipeline is the same. As we've talked about for various reasons, compliance is a much broader sort of an umbrella topic. So we don't see, necessarily as specific subgroups, but we do have some interesting observations. We do see, for example, that topics contain mentions of outpatient or external settings, and that makes sense because that is where you would expect someone who has previously been in the ICU under heavy observation and heavy monitoring may, be exposed to a situation where now compliance is an issue. So references to home, for example, in topics 2 and 5. Topic 3 relates to drug and non-drug related forms of non-compliance. So again, medication is part of the problem, but you might also be given lifestyle change recommendations, diet recommendations. The severity of not following these recommendations will also vary given your underlying comorbidities. So for example, there are references to diet, sodium intake, insulin, etc. And in some cases, if you're non-compliant, for example, on insulin, you could easily die. So the severity will vary, of course. And then topic 6 relates to the affordability of medication. And these are pretty salient recently in the news. For example, there's been a lot of topics about people who have, about people who have been rationing their insulin because they couldn't afford it and have actually unfortunately died. So there's salience to some of these here, although generally less specific than some of the other phenotypes we discussed. And this would be perhaps a good starting point if you were interested in this as a research area to sort of pick a subpopulation there and hone in on the particular aspect or aspects of noncompliance that you're trying to manipulate or trying to identify. in your patient population. So now that we've thought about topic modeling, let's think about ways that we can visualize the distribution over the topics in our corpus. And there's a couple of reasons that you might want to do this. One, if you involve change over time, for example, you can see how the composition of your patient population might be changing. You can also juxtapose topic. First of all, you can assign patients to topics, and we'll talk about that in a second. And once you've done that, you can link your patient matrix where you've got, patient ID, note ID, topic assignment back to your structured data. So for us, in our case, that structured data is Mimic, and we have an OMOP instance of the Mimic database stood up here at DTRI. So that's something that we have access to, and we have config settings that can easily be changed so that you could point to your own database of interest. But the important point here, of course, is that you can link topic characterization to other structured characteristics, including, for example, demographics, including diagnostic values or scores, ICD-9 codes, medications, observations, etc. It's really as much as you have access to, you could consider ways to link. So the assignment of patients to topics in our case is essentially greedy. We take the probability distribution over topics for each document, and we argmax it, so we just select the highest value, and that's the topic that we assign. There are other ways to do this. You could select more than one topic, like N highest or K highest, I guess. You could also select all of them and get the weighted score. But in general, greedy assignment is pretty standard. So we do that, and then from there, we're able to basically visualize the distribution over all the topics in our data set for each phenotype. So the first plot you see here is homelessness. And we notice that the heavy presence of topic 8, which is sort of that lime green topic, and contains the terms number, exposure, prenatal, hospital, multiple, infant, anticonvulsant. So this is interesting, right? There are a couple things to think about here. If you are a mother with an infant or an infant yourself, and you are in the homeless population, you're much more likely to be eligible for and receive social services and other sorts of medical interventions, as opposed to the general homeless population. A lot of shelters privilege women and children over, for example, men. So that's one thing to consider that would sort of bias the distribution. The other thing to consider is that this is a Mimic data set, so these are ICU patients, and disproportionately very young and very old people, including, of course, infants, are represented here. There are, for example, data from NICU patients. So that's something interesting to look at. For insomnia, we've, again, done the same thing, and we see the distribution over topics. We notice that topic 0, which is the dark blue topic, and topic 4, which is purple, both contain words related to sleep apnea, and they sort of dominate the distribution here. And that's perhaps expected because we would expect, sleep apnea is the kind of thing where you do get a recommendation for a sleep study and you are likely to complain of insomnia. Finally, we look at compliance, and we see that topic 6, which is the pink topic, is heavily represented, and that's related to the affordability of medication. So that does sort of validate our thinking going into this process that affordability might be a key reason that people do exhibit noncompliance. So I'm going to turn it back to Charity to talk about how we can sort of join some of this information and look at it along demographic lines.
Yeah, so as sort of we were looking at these populations, we sort of come up with how populations are assigned to groups based on terms and being found with Engrams and provider assertion. But we also have sort of groups of patients by topics. So some of those topics that were identified with topic models, maybe want to visualize and dig into those sets of patients further. So here we created a pretty simple way to join with the demographics data. In our case, since we don't really store demographics data in our Solar source, we have to join it back to the structured database. So this isn't something that would be done in Clarity natively, but it's certainly something if your data set uses the same identifiers, it's pretty easy to do that linkage. And sort of the benefit of that is once we find all these unstructured topics and things that sort of are salient for us, we want to link back, and we can do lots of different things with that. So we can find basically just how our population is distributed. Maybe we want to target people for a study or specific intervention. So not only do we have these patients, but we also have them by demographics or other characteristics. So it's pretty easy. Do you want to flip over to the just query that I built?
Sure.
So in this case, since Christine went ahead and was able to load in to assign the patient ID in the topic model, I'm easily able to get that out. And all it's doing here, I have a config file, which is just loaded from the file system. And then once I do that, I pull in the database properties. And all I'm doing here is a simplistic demographics query on OMOP. So because we're using OMOP data and we have the OMOP IDs, we can easily get all this from the person table. So what I did was just basically get list of persons, get their race and their gender. Obviously, there's other axes that you could query on. You could query on observations or medications. You could do, it doesn't really work in Mimic because we use, the dates are offset, but you could do, if, in a more realistic data set, you could do ages if you wanted to bucket by age. So there's certainly lots of demographics you can query on. So do you want to go back to the main notebook? So basically we just did this, so I ran a query. I took all the patients that we found in the homelessness data set. I found 324 unique patients. Like I said, we just did a subset of overall mimics, so it makes sense that that's pretty small. And basically what we did for each population, we did a distribution based on race and based on gender as well. And sort of like what you would expect for the mimic population. If you look at the overall statistics on the mimic population, as far as race goes, this is pretty representative of that population. So it's a mostly white and then African American population. But homelessness, you can see, which is kind of like the intuition around homelessness, is there's many more males that are in the homelessness data set than females. So that sort of gives us some information. And again, this is on the overall population. Scroll down a little bit. So if we look at insomnia, sort of same kind of thing. There are 459 patients. Keep going. But here we can see the gender is a little bit more balanced. There's still more male than female in this data set, which is kind of interesting. Don't know why that would be. Maybe it's just a nature of the data set or the terms we selected. That's still unclear. And then poor compliance was the last thing we looked at. And then we did race as well as gender. And on that, we see a much more even distribution between male and female on poor compliance, which makes sense because, like we've mentioned, compliance is sort of a much more broad set of terms and much more broad set of things. But if we wanted to explore into these further, maybe by other areas, we could do that as well. So the last thing that we wanted to do was look at by topic. So in this case, I think, can you scroll back up to homelessness and see what topic 4 was?
Sure.
So I picked a topic out of homelessness, and I wanted to see if there was any additional insight we could gain. So this is more related to abuse, so ETOH, alcohol abuse, hepatitis. So that might be related to substance abuse issues. So I wanted to see if there was any additional information we can glean from that. So I was able to filter on a specific topic. And it's pretty similar, so we don't really gain too much information, but it's a good metric to have so we can sort of dig into each of these topics further if we want to visualize. And like I said, it doesn't have to be limited to demographics. And then we sort of did a similar thing on the other topics and other areas as well to try and understand those better. So we can obviously come back and link all this together. And I think as we continue to develop this notebook and continue to develop sort of these exploratory data analysis tools within Clarity NLP, we'll continue to build out these things further and hopefully continue to have cooking sessions to share back and features that we build back into Clarity NLP. So I'm going to pass it back to Christine to wrap up. If we have any questions, it looks like we got done pretty quick. I guess we were blazing through it.
Yeah. So I'll make 2 final points before we wrap up here, and then of course we would definitely invite questions. We have a fair amount of time left in the session, so don't be shy. 2 things that I did not get a chance to integrate into this notebook yet, but that I do hope to pretty soon, and I'll be updating our GitHub with the final version of the notebook. So keep a lookout. One is that, for example, the type of plots Charity just walked you through, we could also visualize the distribution over topics at a crosstab level. So, for example, the plot I'm showing on the screen right now shows the distribution over all topics, over all patients. You could easily bifurcate that on one or perhaps even multiple demographic lines or diagnoses lines. So, for example, like among patients who have diabetes, what's the distribution look like among men versus women, among people of certain ages, and so on and so forth. Like these are pretty simplistic first passes at how you might split the data set for crosstab purposes, but we can certainly imagine more complex and interesting ways to do it. Another thing we can think about is clustering. So, for example, by taking basically the bag of words representation of each note, we can represent that in a lower dimensional space and color the cluster based on topic assignment, for example. And on the same plot, we can superimpose known structured characteristics of the patient. So, for example, race or gender or, again, age or any of these things that we might be interested in seeing. This is particularly useful in cases where you have a known diagnosis that manifests very differently across different subpopulations. So, autism is one example where we might have many different manifestations, many different subpopulations of interest, not a real precise clinical definition of traits that you exhibit or characteristics that you have if you're diagnosed with this thing. So that type of thing where you have a broad category and you do want to understand the clusters, the neighborhoods, the similarity within and among patients of different types. We're working on that, and we're sort of expanding into that space as we move forward with Clarity. We're also thinking about how to parallelize this for larger data sets. So the mimic data set, and in particular, the subpopulations that we've queried for here are relatively small. So the computational complexity is not really a factor. We haven't run them, for example, live right now, but if you clone the notebook and run it yourself, you'll see that they generally don't take more than maybe 5 minutes at most. Mm-hmm. That's not going to be the case if you have a larger corpus, and you will run into size constraints, memory issues, that kind of stuff. So we are thinking about that. We're aware that it's a scale issue as we move forward in development, and it's something that we are going to be prioritizing. So I think that's all we have for now. So
yeah, I wanted to. We can go into questions. I also wanted to. Can you bring up our documentation page?
Sure.
Sorry. Yep. So I just wanted to mention one more thing that we added. So can you click on API reference? So we added an API reference. So this is kind of a thing that people have been asking for with ClarityNLP. And it basically has sort of all the features and all the arguments that you can run. So if you click on Engram, for example, so this is how you would call Engram and NLPQL. So in all these, we try to provide an example. We try to provide what arguments get passed in, whether they're required or not, and what results you get back. If you scroll up, you can also click on the base task. And basically all our Clarity tasks extend this base task. And they're basically all the sorts of things that these are like the generic things you can pass in to every Clarity NLP task, and also the generic things that come out with every task. So just know when you're querying Clarity or you're doing some of this cohort stuff with building with Clarity, you always get these features. Can you go back up one? Back up to the main API reference. So scroll down. So I also have added some of the other APIs that we have. Obviously, our main focus is around NLPQL and Clarity, but we do have some other APIs that you may want to run. So just wanted to sort of highlight that documentation and let people know that it's out there. Can you go back to the top and click on cohort? Mm-hmm. Sure. So this is sort of the two cohort features that we have. So obviously, if you have an Odyssey instance, you can get a cohort of patients from cohort. But then you also have this new thing that we've implemented, which is to find patient cohorts from Clarity. And you can sort of see all the parameters that we have. So these are basically all the things that Clarity generates. But you can also take really any generated feature from Clarity and query on it. So you can basically do like queries within queries and do the chaining that as we described. So all this is implemented and it's in Clarity, and it's ready to be used with NLPQL. So just wanted to highlight those things. But I think we can pass it over to questions if anybody has any other questions or anything else they want us to answer regarding anything related to Clarity, we can certainly do that.
Hey, this is Lee Cromwell. I'm brand new to NLP. I'm trying to figure this out to begin with. But is there a way to get access to your sessions 1 and 2?
Yeah, so that's on the GitHub page. Can you bring up? Yeah, so you can go to our GitHub page and then click on the wiki. So if you go to, yeah, so this is the right link, github.com/ClarityNLP, and then click on the wiki. And then on the wiki page, there's a subpage called Cooking with Clarity NLP, and I have the previous notebooks and the previous recordings. Some of the recordings are not great, but I'm trying to improve them every week. So it is a work in progress. But and then there's a lot of information in our documentation that we just showed. So we have documentation on setup from like a developer side, but also from a user side, and sort of walk through. So we've kind of like bifurcated that like documentation. So you're like how you go about these things when you're a developer, and then we have the user guide, which is sort of more like the John Duke clinical approach. So we sort of walk through each of those. So both of those are available as well, in addition to the previous cooking sessions.
Oh, thank you.
And yeah, they're living documents, right? They're all on GitHub. So if you notice errors, have issues, have questions, etc.
Yeah, we're working on them every day, so everything is a work in progress. Everything is getting better by the day as we build this stuff out. So. Yeah, and if there's ever any features that you want to request, you can reach out to us via GitHub or email me. I think my name is on the invite that John's sending out, and it's just charity.hilton@gtri.gatech.edu. So I think that's a good way to get in touch with us. Also, just through GitHub, we're always watching that, so you can reach out to us through that as well. We also have a Slack we can invite people to if you're interested in asking questions to us directly. Okay, well, I think we can wrap it up then. If there aren't any more questions, we have these sections every 2 weeks. So some upcoming stuff that we would like to do. We would like to do more integration with OMOP and Odyssey. So we want to talk about that. We'll probably have more machine learning stuff in the future, maybe later in the year. And then we also want to do sort of a basics, starting from the ground up, how to set up Clarity, how to ingest Clarity. Because we've kind of, in the previous notebooks, we sort of did a full end-to-end, but it was pretty broad, but not very in-depth. So now that we've sort of done those introductory ones, we wanted to dig more in-depth to sort of set up and stuff like that. So that's stuff to be looking forward to. And like I said, if you have any requests, feel free to reach out to us. My email is also on this page. So, all right. Well, with that, I will wrap it up. And thanks everyone for joining. We look forward to you guys in 2 weeks. Let me stop the recording.